Physics Part 260. Question number 3. There are two similar table tennis balls, each of mass 2.5 grams. The balls have equal charges and are suspended by insulating thread. A. Calculate the tension in one of the threads. B. Show that the electrostatic force between the two balls is 1.4 into 10 power raised to minus 2 Newton. Calculate the charge on each ball. Question number 4. A capacitor is made from two strips of metal foil, 50 millimeter wide and 50 millimeter long. 50-meter long, I beg your pardon, please. With paper of thickness 0.10 millimeter between them. The relative permittivity of paper is 2.0. Calculate the capacitance of the capacitor. The strips are then rolled up into a cylinder to make the capacitor easier to handle. However, a second sheet of the paper must be applied on top of one of the metal sheets. Explain why this is necessary and why the acceptance of the rolled up sheet is greater than that in a permittivity of free space. Question number 5. Well, the figure illustrates the apparatus used by Cavendish in 1798 to find a value for the gravitational constant g. In a school experiment using similar apparatus, two lead spheres are attached to a light horizontal beam which is suspended by a wire. When a flask of mercury is brought closer to each sphere, the gravitational attraction causes the beam to twist through a small angle. From measurement of the twisting torsional oscillation of the beam, a value can be found for the force producing a measured deflection. G can then be calculated if the large and small masses are known. Well, in such an experiment, one lead sphere has mass 6.22 into 10 raised to minus 3 kilogram, and the mass of the mercury flask is 0.713 kilogram. Calculate the force between them when they are 72.0 millimeter apart. Gravitational constant G is equal to 6.67 into 10 raised to minus 11 Newton per meter per kilogram. Comment on the size of the force. Question number 6. 2-point charges of plus 2.4 UC and in minus 2.9 UC are placed at the points A and B respectively in a vacuum 0.15 meter apart. It is required to find point P at which the resultant electric field due to these two charges is zero. A. Explain P cannot lie off the line joining the charges, extended if necessary. B. Decide whether P can lie to the left of A between A and B, the right or to the right of B, or in a more than one of these regions. Give reasons for your answer. C. Hence, deduce a location for P. Question number 7. The gravitational field strength at the surface of the moon is 1.62 Newton per kilogram. The radius of the moon is 1,740 kilometer. A. Show that the mass of the moon is 7.35 into 10 power raised to 22 kilogram. B. The moon rotates about its axis as well as moving in orbit about the Earth. In future, scientists may wish to put a satellite into an orbit about the moon such that the satellite remains stationary above one point on the moon's surface. Number 1. Explain why this orbit must be an equatorial orbit. Number 2. The period of the rotation of the moon about its axis is 27.4 days. Calculate the radius of the required orbit. G is equal to 6.67 into 10 raised to minus 11 Newton per meter square per kilogram square.